that form is known as standard form or negative null form. And this is a slight variation on the set of equations that we have written before, and the variation is this, that you write your objective function as is, and here we have changed slightly in a different way. Instead of writing minimize, we have write min, which is like the minimization. With respect to the variables are written as LWH, which are the variables that are going into the overall objective function, the three variables that are there. But we know that this H is equal to capital H. So essentially this problem has only two variables. And then what you do is you rewrite the constraint in such a way that you have 0 on the right hand side for all the equations, constraint equation. So you can see in the previous slide, we have written the equation slightly different. On the right hand side, we had one V and H, whereas for this one we had 0 and 0. Okay. So in this way, we are writing it in slightly different format, where we are bringing the V back here and the capital H here, so that we have 0 on all the equations on right hand side. And the second thing that we are doing is the inequality constraint that was there in the previous one. We are writing that in this way, where we have less than equal to. So we have multiplied a negative to L, and that negative L has to be less than equal to 0. So that's the negative form, and the null is on the right hand side. All the zeros are on the right hand side, and this combined information gives to this idea of negative null form. And negative null form essentially ensures that the physical entities in our problems are greater than 0, and they are written in this way. Okay, where we are writing the constraint is always less than equal to 0. Okay, so L has to be greater than 0 or greater than equal to 0. That could be written as minus L is less than equal to 0, and this is the standard way of writing the overall optimization function. Now the question is, what is the difference between the previous one and this one, and why is that important? Now typically, whenever as you can see, first of all, you have to standardize, because there are different ways to write the overall formulations or overall problem. And typically in optimization literature, people follow the negative null form, and they take this as a standard. And reason for that is most of the optimization code that you will do in MATLAB or Python or other things, you can create functions that can solve for this class of problems. Okay, it turns out those functions take the input of the objective function only in negative null form. Most of the functions which are there in the softwares and code assume that you will provide the input problem, optimization problem, in the negative null form. So if you take the previous one and if you use that and provide that to MATLAB code or a Python code, then you might get errors. Okay, because you need to have a standardized for the coding functions. They make an assumption that the user will be providing them the problem in negative null form. So, when you have a problem, first thing that you need to do is take that problem, write the objective function, and convert the equality constraints and inequality constraint in negative null form, and then only you should be able to pass that on to code, and that code will solve. That's one thing. So again, there is a standardized way of writing it, and the standard way of writing this is known as negative null forms. That's one of the concepts. The other thing that I want to emphasize, that constraints could be of two different types. One, you can see you have equality. This is equal sign, right? Whereas these two equations have less than equal to signs that are there, right? So this equations, the equation set of equations which has equality sign, are known as equality constraints. Remember, all of these are constraints, but since we have equality sign, these two are known as equality constraints, whereas these two, where we have less than equal to sign, those two constraints are known as inequality constraints. So the constraints could be of two different types, equality constraints and inequality constraints. And it's important to know whether your constraints are equality or inequality constraints. Going forward, we will see the effect of equality constraints and inequality constraints, and it turns out that equality constraints are very, very restrictive. So if you have too many equality constraints, the challenge or solving the problem becomes, somewhat difficult. Okay, whereas inequality constraints are more relaxed and they're more helpful. But as we proceed, you will see the differences between and how the equality constraints and inequality constraint affect the solution of the problem is going to be important. Okay, so that's some background information about optimization. You have to, there is a negative null form I described, and then you can have equality and inequality constraint. So let's go back and try to solve the problem that we have formulated. Remember this same problem that we have formulated. Let's think about how can I solve this problem and how can you use this information and provide this information to the carpenter for which we have formulated this problem.